Welcome to the Explainer. Look, we've all been there. You get a module with a dead pixel, right? Usually it's just a cracked LED bead from a simple bump, maybe some excess pressure, or just poor soldering. But sometimes it goes way deeper. You pull off that broken bead and bam! The microscopic copper pad underneath is completely lifted or ripped off. Talk about a headache. Today, we're diving straight into how to handle these lifted pads so you can rebuild those connections and restore your modules to absolute perfection.
To get you repairing like a pro, here's our game plan. First, we'll tackle the lifted pad problem. Then unpack the LED circuitry and scan lines. After that, we'll look at PCB pad repair methods, walk through the step-by-step fix, go over testing and measurement, and wrap up with best practices and a summary.
All right, Section 1, the lifted pad problem, diagnosing the true cause of a dead pixel. Let's get right into this incredibly frustrating issue. The main takeaway here, a dark pixel after a lamp bead replacement is often blamed on the LED, but a damaged pad can actually produce the exact same symptom. If you've got a dropped module and you remove the cracked bead, you might find that the pad underneath is just completely gone. You literally cannot just slap a new bead on there. You have to do a full pad rebuild first.
So how does this even happen? Well, physical impact, excess pressure, water damage, or just poor soldering can rip that pad right off the board. Maybe the module took a hit, or maybe repeated rework fatigued the copper. Whatever the root cause, a lifted or carbonized pad completely severs the electrical connection. So yeah, a simple bead swap just isn't going to cut it here.
Section 2. LED circuitry and scan lines, the anatomy of the LED and pixel control. Before we even think about grabbing the soldering iron, we really need to unpack how the LED actually interacts with the module's circuitry.
First things first, you've got to identify your board setup. Are you dealing with a common anode or a common cathode? Remember, an RGB LED is actually 3 distinct microscopic LEDs packaged together. Depending on the board, they either share a ground, which is your common cathode, or a 5-volt supply, which is your common anode. Now, with a common anode, the RGB legs act as current sinks. That means you counterintuitively have to drive them low, meaning 0 volts, to turn them on. Knowing this completely changes how you troubleshoot. When you're looking at that SMD LED, you'll see 4 distinct pins. That small notch corner, that marks your positive or anode pin. The bottom left is red, bottom right is green, and top right is blue. These connect to independent R, G, and B driver ICs. If your PCB and pad placement are misaligned, say you accidentally rotate the bead, it's going to show the wrong color entirely. So correct alignment is absolutely crucial.
Now, let's zoom out a bit to scan lines. Scan mode is basically the ratio of the number of lines lit at the same time to the number of lines in the entire area. So a 1/4 scan means a quarter of the total rows light up at once. This multiplexing directly impacts your screen's brightness and lifespan.
So, quick quiz for you. What happens if one driver chip fails in a 1/4 scan module? Well, since separate chips drive the red, green, and blue channels, if a single red channel chip fails on a 4-scan module, boom, you instantly lose red on 4 entire rows. It creates this super obvious dim line or cross effect radiating right from the failure point.
Section 3. PCB pad repair methods. This is all about choosing your approach to reconstruct the circuit. We know the anatomy now, so let's look at how we actually rebuild these broken traces.
You basically have 2 main ways to handle this. Option A is using a copper foil patch, often called pad paper. This is best for entirely replacing a missing pad with adhesive copper. Option B is a jump wire, or flying wire, where you bypass the damage entirely using a 0.1 mm enameled copper wire to connect to a nearby node. Both ways get the job done and let you successfully solder down your replacement bead. Moving right along to Section 4, the step-by-step fix. Let's execute this physical repair. Here's the exact workflow. Step 1. Clean up the damage and expose a tiny bit of the healthy copper trace. Step 2. Apply some PCB glue and secure your copper tape or jump wire. Step 3. Solder the new LED bead into place. And finally, Step 4. Once everything is tested, apply a UV mask or sealant for strain relief. If you're using pad paper, make sure it sits perfectly flat before you put the bead down.
Now, if you're going the jump wire route, you have to follow strict line management rules based on the principle of proximity. Bridge to the nearest identical pin. For RGB pins, only bridge vertically, up or down. For the positive power pin, only bridge horizontally, left or right. And here is a huge one. Never cross the IC boundary. So, if the 16th pad is missing, do not bridge to the 17th LED, because you're crossing into a totally different driver chip's territory.
Section 5. Testing and measurement.
verifying the connection. Don't even think about sealing up your work until you've verified the electrical integrity.
Always power down the module before you start probing around. You want to check continuity to ensure those electrical paths are unbroken, check your DC output voltage, and definitely look for shorts, which usually show up as unexpectedly low resistance. Oh, and here's a pro trick for PCB pin measurement. You can lightly short adjacent pads with tweezers while the board is running a test pattern. Like if you short a green pad and trigger a red bar, you instantly confirm the red channel trace is alive and well.
Actually, here's an even better continuity trick. Just place your multimeter's red probe directly on the repaired pad and the black probe on the common pin. Doing this pushes just enough current through the circuit to make that specific LED channel give off a faint glow. It's an awesome way to visually confirm your pad paper line and pins are fully connected before you even plug the module in. Finally, Section 6, Best Practices and Summary. Let's make sure this repair has long-term stability.
You want to avoid overheating your epoxy or glue during soldering. Make sure any jumper wire is super short, flat, and insulated. If it sits too high, the LED mask is just going to crush it. Watch out for misaligned pads. If you accidentally route a red pad to a green trace, your colors will be totally distorted. Line management is literally everything here.
And a quick note on temperature, 370. That's 370 degrees Celsius. When you're using unleaded solder, keep your iron precisely at this temp. If you go too hot, you'll instantly melt your new adhesive or lift the surrounding healthy pads. So speed and temperature control are definitely your best friends.
To wrap this all up, broken beads often take the pads down with them. But by using conductive materials, precise soldering, and thorough testing, you can totally restore the module. Knowing this fix is a real superpower for sure. But I'll leave you with this one question to chew on. When is a pad just too carbonized to save? At what point of severe PCB damage is stepping away and replacing the entire module actually your safest bet? Think about it. Thanks for joining me on this explainer, and happy soldering.